Hello, sir.
Hello.
This is our demonstration for our music box project. That's three of us right there. So here we have our input module, 13 buttons, debounced with a capacitor and 2 resistors. Then we have over here our input combination because we need to reduce the 13 inputs down to 8. So the signal will go over here to this set of diodes where this goes to the counter, and these are going to go to the I/O pins, which are going to be down on the board here.
Now, normally the counter would head, the counter wire would head here, and it would increment the count every single time. Is it on right now? Yeah. See, like the
You can
counter.
also turn the clock on.
The counter increments, but we are having trouble getting it to work with our memory. Memory circuit is over here. This 8-bit, what do you call this?
Dip switch.
A dip switch, like tells the memory what address to store information at, and this one here is normally connected to these yellow wires, and this is the data. So let's say like the first one is on after a push of a button, then it's gonna store at whatever address is listed here from the counter. It's gonna store the first input, and the first input, if we trigger, well, right now it's on right now, but the first input
so
here it's 0.
address 0.
Yeah, we have light 1 from the I/O pins, and it now triggers note 1, which we follow this black wire, goes to A here. And then if I switch the address, right now it's in output mode. You can see that this one is pulled high. The right enable is pulled high. The output enable is pulled low. So every time we switch the address, it just outputs right away what was stored. So you can clearly see that something is stored right now. And now I/O pin 2 triggers note 2. Black wire here triggers a different frequency, but we're having trouble with our speaker right now. What address did we store a double on? No, not this.
Go back. I think 3. Like 3 of them.
1 1.
1 on 1. No, maybe one more. There we go.
Yeah. Okay. So we explained earlier that we have 8 wires for 13 notes. So sometimes we're gonna have a double. The double here should be the 9th note because the first 8 each have their own respective one. Then this double, it should be the 10th. This double would be the 9th, and this double should be the 10th. So if we look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Because the first double triggers the 9th, second double triggers the 10th, third double triggers the 11th. And so on, that would trigger the speaker. Alright, this is the clock module now.
Yes, so for the clocks, what we have is we have 2 555s. The first one is set up in such a manner that we have a potentiometer to control the speed of the pulse. That controls, obviously, the speed that the capacitor charges at. And then we also actually have a diode set up here so that the resistance in and out is the same, which means we have a 50-50 duty cycle. So we have an evenly timed clock on and clock off. And so this controls our playback speed. Currently we have it set up here clocking the output here, so we can see, the counter incrementing at speed. So obviously if I change the speed here, it'll go, in this case it'll go a little slower, or if I turn it all the way up, it'll go a bit faster. The first counter then also, its voltage input, its reset input is controlled through a transistor, which this flip-flop controls. The idea behind the flip-flop is that in our full circuit, if it was functioning, once the count hit 32, it would trigger the flip-flop to then start playback automatically. In our case, we need to press a button to do it currently. And so we have our first switch, first 5x5 rather, which is again pulsing around like, say, 1 hertz or 2 hertz or something like that. And it controls another transistor, which controls the reset pin for the second clock here, which actually generates the frequency of the note. And so this one connects to this set of resistors here, like Gabe was showing earlier, whereby the input of whichever output we have here, inputs goes through a diode, through a set of resistors, and so the current varies depending on the resistance, and it charges the capacitor of this second one at varying speeds. And this is how we get our different frequencies out of it, which would then go, as we can see here, go to our speaker setup here, connected. For some reason, once we assembled it all together, it's not actually making noise. It was making noise like 5 minutes ago, but here we are. That's the current
how everything
status.
works. Hopefully tomorrow you'll get to see
I was gonna
a fully
say,
working circuit.
We'll try to tweak it.